Today's world is different for our children, vastly different from the one we grew up in. The technologies we take for granted or simply don't understand have become an integral part of our children's identities. These technologies saturate practically every aspect of their daily lives. This digital bombardment is shaping who they are and who they will become. We must realize they live in a different world and speak a different language. If we ever want to take part in nurturing those who will be the architects of our future, it's up to us to learn that language and step into that world, to allow them to lead us inasmuch as we must lead them, so that we may truly understand the digital generation.
So a question you might ask is, how do we know this stuff? Well, we know this because of something called the Human Brain Project and the International Consortium of Brain Mapping, which is a project that has been ongoing for more than 15 years at major universities around the world. And you see, during that period of time, a brand new field of brain studies emerged. It's called neuroinformatics. Now, neuroinformatics involves the analysis of brain processes by the means of neural scanning and imaging using the incredible number-crunching power of computers together with our growing understanding about the biology and the chemistry of the brain. And you see, using really powerful brain scanners, they're called fMRIs, functional magnetic resonance imaging systems, we can now, for the very first time, get inside the black box known as the brain. We can actually now examine living brains non-invasively while they are in very specific processes of thought. And you see, using these technologies, researchers can view not only in real time, but also in 3 dimensions, what parts of the brain are being used to perform specific mental processes. I have to say, folks, this is absolutely amazing because see, these technologies and these techniques are now allowing researchers to be able to pinpoint to within a few millimeters the parts of the brain that actually light up or turn on when we do things like view vivid colors, when we see pictures of yummy, calorie-rich desserts that we're not supposed to be eating, when we stare at pictures of scary faces, even when we do something as simple as move a finger, feel sad, add 2 + 2, or do a specific mental task. And you see, literally decades of research have now shown that intensive, sustained, and progressively challenging stimulation and focus over extended periods of time, what we call digital bombardment, can profoundly affect neural pathways, changing the pattern of neuronal activities in response to experience. This actually changes both the brain's physical structure and the functional organization from top to bottom. In fact, Canadian psychiatrist Norman Doidge, author of The Brain That Changes Itself, has stated that neuroplasticity is one of the most extraordinary discoveries of the 20th century. Digital bombardment has a particularly strong influence on an area at the back of the brain known as the visual cortex, okay? So let's talk for a moment about the effect of digital bombardment on the visual cortex. Now, I'll go off on a bit of a tangent here by saying that the average video game takes about 40 hours to play and master. The complexity of the puzzles, the complexity of the objectives grows steadily over time as the game progresses. And now, a recent study by the University of Rochester has found that visual processing skills dramatically increase with as little as 10 hours of gameplay. Their initial conclusion is that game playing is reshaping the brain. It goes without saying that these developments hold enormous implications for educators. According to developmental molecular biologist John Medina in his amazing, hilarious, and incredibly informative book called Brain Rules, tests have shown that people can remember the contents of more than 2,500 pictures with more than 90% accuracy several days after exposure, even though the subjects see each picture for only about 10 seconds. Recall rates a year later still hovered around 63%. But the same research says that if new information is presented orally with no image present, people only remember about 10% of what was presented, okay? What this means is that after just 72 hours, Students are only going to remember about 10% of a lecture. If that's the case, a question we have to ask is our traditional stand and deliver full frontal lecture model, is it effective? And the answer to it is obviously not.